Okay, so we're talking about probability now. Probability today, okay? Probability is actually kind of fun. Anybody know what probability? Can somebody give a definition of probability? Yeah.
It's the possible number of times something will occur.
Possible number of times something will occur. Kind of, yeah. Sean, what are you going to say? How likely something is to occur. Okay. Okay. Yeah, those are all good. Okay. So the probability of an event, we're going to call it P event here. All right, is the number of times that event is going to occur over the number of, and we call this a sample space. Sample space. That's,
Sample space, like the number of times you do it.
the sample space is all possible outcomes. How many total possible outcomes there are, okay? So the sample space is total possible outcomes. Alright, and the event, this is how many times your particular thing you want to happen, okay? So this is the particular event you want to happen. Okay? And this is, and then the bottom, the denominator is always the sample space, which is the total. Okay? So they're always fractions. Okay? For decimals. So for example, we roll 2 dice. Okay? So if you roll 2 dice, okay, first let's figure out the sample space, because you always need the sample space for probabilities. So what are the total number of possible outcomes that you could get from rolling 2 dice? We got 1 die, we got 2 dice, right? So the first one there are 6, and the second one there are 6. So the sample space is 36, okay? Just like how we started off this whole section with the counting, there's 6 ways the first die can come out, there's 6 ways the second die can come out. You got to multiply those, because let's say the first die is a 1, all right? That could go with a 1, 2, 3, 4, 5, or 6, right? So if the first die is a 2, that could go with all 6 of those. 3, so you got to multiply those, all right, to say how many total there are. Okay, so let's say that, let's do just a couple examples here. A probability of rolling a 7. I mean, total of 7. Obviously, you can't roll 7, but a total of 7, right? So what you got to do is you got to say, well, how many ways are there that you can get a 7? And that's what's going to go on top. Okay, and the 36 is always going to go on the bottom if you're rolling 2 dice. All right. So now, for me, I mean, it's probably just easiest just to count them up. There's not going to be that many. Okay. So to get a 7, you can get a 1 and a 6, right? Or a 6 and a 1. 3, 4, 4, 3, 2, 5, 5, 2. Okay, 1, 2, 3, 4, 5, 6. There's 6 ways that you can get a 7. All right. So the probability here is going to be our 6 ways that we can get a 7 over how many total things that could possibly happen. It'd be 36. So I think you can reduce that, right? Yeah. Okay. Let's talk about the probability of A and B. The probability of A and B happening, okay, is the probability of A happening times the probability of B happening. Okay, pretty straightforward. The probability of A or B happening, okay, A or B happening, is going to be the probability of A happening plus the probability of B happening, because either one is good, okay? But you got to be careful on this one. There's a strange thing that can happen, and you'll see why in a second when I do an example. We have to, if you have an OR, you have to subtract the probability of A and B happening. Now, why would you have to do that? Anybody see? Because what?
You couldn't have something where A and B happen that
Okay, no, you're on our track. But if A happens, we're counting it right here, right? If B happens, we're counting it right here. If A and B happen, we're counting it twice. Okay? And we don't want to count it twice. So we got to subtract off one of those, and that's what this term does. This term takes care of all the overlaps. Okay? So that's the overlap on an A or B problem. Okay? So you'll see. I'll do an example of that in a sec. So let's say that let's roll 2 dice again. And let's say what's the probability that both are odd? So is that A and B or A or B? That's and, because they both have to be odd, okay? So the probability that the first one is odd is what? How many odd numbers are there on the die? There's 3, right? So the probability that the first one is odd is 3/6. And the probability that the second one is odd is 3/6 again. That's just, you can reduce that. That's 1/2 times 1/2, right? So that's 1/4. So 1/4 of the time, you're going to get both odd dice. Okay? Now, but what happens if we say the probability that either one is odd? Okay. No, that's just both are odd. This is probability either one is odd. If we say the probability either is odd, so the first one is still 3/6, right? Well, if we say that, and the second one's 3/6, if we just left it at that, what is that? That's 1. That's everything. That means it's always going to happen. Well, it's not always going to happen. And so that's what this subtracting the overlap does. We have to subtract the probability of both happening, which we already found out right here. Okay, so we got to subtract that 1/4. So that's going to end up giving us 3/4. Okay. Let's say you have a 52 card deck, and we're going to pull one card. What's the probability that it is a heart or a 7? A heart or a 7. So this is an OR problem, so we've got to add those probabilities, right? So the probability that's a heart is what? 13 out of 52, or you could reduce that to 1/4, right? The probability that a 7 is 4 out of 52. You can reduce that to 1/13. Okay, but there is a card that is a heart and a 7, right? Okay, so we don't want to count that card twice. We don't want to count it as a heart and a 7. We can count it as either one. But the way to take care of it is to subtract off that overlap. In this case, it's just that one card that is the overlap, right? So you would subtract off 1 over 52. And I think that comes out to 14 over 52. You can reduce that more, but I'm not going to worry about that right now. Okay? I'm sorry, it would be 16, yeah. 16. Okay, so that's the overlap. Now, any valid probability distribution, don't worry about these big words, distribution. Any valid probability distribution must add up to what? Yeah, must add up to 1. Okay? That's 100%. That's everything. Okay? I'm going to actually stop right there and continue in a second.